The last time we discovered that if we have a function f of two variables, so f is a function from R2 to R, and we want to integrate f over a rectangle. Here I'm going to draw the rectangle. This is the rectangle where x goes from A to B and y goes from C to D. Let's call this rectangle R. If we want to compute the integral over R of f of x, y, dA, we discovered last time this is equal to the integral from A to B of the integral from C to D of f of x, y, dy, dx. This is a formula that we can use to actually evaluate integrals in the special case where the region that we're integrating over is a rectangle. So let's use this formula to evaluate this integral, just as an example. Suppose f of x, y is equal to, and it's going to be x squared times y, and we want to integrate over this rectangle, the rectangle where x goes from 0 to 3, and y goes from 1 to 2. Here, x goes from 0 to 3, and y goes from 1 to 2. We're integrating over this rectangle here. We'll call this rectangle R. So the integral over R of x squared times y dA is equal, according to this formula, it's equal to the integral from 0 to 3 of the integral from 1 to 2 of x squared y dy dx. Now let's look at how to evaluate this inner integral here. How do we evaluate this integral? Now when we're looking at this integral, keep in mind we're integrating here with respect to y, and x is held fixed. So when you're looking at this inner integral, you can think of x is held fixed. We're integrating with respect to y. And we know how to integrate this function of y from single variable calculus. How do we do it? We just find an antiderivative of this function of y. X is held fixed. It's like and we want an antiderivative of this function of y. The answer is x squared times y squared over 2. That's our antiderivative with respect to y. And we take our antiderivative and we evaluate it at the endpoints. So we evaluate our antiderivative from 1 to 2. That's how we do an integral in single variable calculus. Okay. So let's work this out. X squared times y squared over 2 evaluated from y equals 1 to y equals 2. Well, when we plug in 2 for y, we get 2x squared. And when we plug in 1 for y, we get x squared over 2. And so this is equal to 3/2 x squared. So what we just did is we evaluated the inner integral and we got 3/2 x squared. So where are we now? We have discovered the integral over R of x squared times y dA. This integral is equal to, and what do we have up here? We have the integral from 1 to 3. I'm sorry, from 0 to 3 And we already evaluated this inner integral, and it turned out to be 3/2 x squared. So this whole inside integral is, it reduces to just 3/2 x squared. And then we still have this dx here, so dx. Okay, so now all we have to do is evaluate this integral. Now, once again, this is an integral we know how to do from single variable calculus. How do we do it? We just find an antiderivative of this function that we're integrating. And so what's an antiderivative of this? Well, it's x, it's 1/2 x cubed. And we take our antiderivative and we evaluate it at the endpoints. So we evaluate it from 0 to 3. Okay, when we plug in 3 for x, what do we get? We get 27/2. And when we plug in 0 for x, we just get 0. So our final answer is 27/2. That's our final answer.